So today, we're going to dive into a story that stretches from the massive frozen sheet of Greenland all the way to coastal cities, pretty much everywhere. It's a story about how these huge, planetary scale changes in our climate are directly connected to the real lives and jobs of people in very, very different places. Okay, let's get right into it. I know it seems like a massive leap, right? But the connection is actually surprisingly direct. And that's really the core question we're going to unpack here. How a physical process way up in the Arctic can send ripples out across the globe, literally reshaping economies and forcing some really tough choices on coastlines everywhere. To really get these connections, first, we gotta zoom out and look at the big picture. These enormous atmospheric forces that are basically the planet's climate engine, especially over the North Atlantic. Okay, so here's a key player in all this, the North Atlantic Oscillation, or NAO. The easiest way to think about it is like a giant climatic seesaw. You see, when the atmospheric pressure is high over the Azores and low over Iceland, you get strong winds that bring warmer, wetter weather to Northern Europe. But when that pattern flips, so does the weather. This back and forth is a huge reason why ocean conditions and even fish populations can change so dramatically over the years. And the impact of these shifts is, well, it's staggering. Look at this number, 219 gigatons. That's the average amount of ice Greenland has lost every single year for the last 2 decades. Now, a gigaton is a billion metric tons, so we're talking about a volume of fresh water that's almost impossible to wrap your head around, and it's all pouring into the ocean. This doesn't just affect sea levels, it messes with the circulation of the entire Atlantic. All right, so let's bring this down from these huge planetary forces and see how this stuff actually plays out on the ground. We're going to look at this really fascinating case study from West Greenland. It shows how 2 communities, right next to each other, went through the exact same environmental change, but had completely different outcomes. This timeline tells a classic story of boom and bust. For decades, Atlantic cod was basically the entire economy for West Greenland. Warmer waters brought the fish, and a whole industry just shot up around them. But then in the 1960s, it was this 1-2 punch of cooling oceans and just way too much fishing. The cod stocks totally collapsed, and it forced this massive economic pivot. This whole history really sets the stage for our tale of 2 towns. And this is where you really see the 2 different paths these towns took. Paamute, well, they put all their eggs in one basket, cod. So when the cod vanished, their economy just crumbled, and people had to leave. Sisimiut, on the other hand, had a more mixed fishing economy. They were already catching other things like shrimp, so when the cod disappeared and the shrimp fishery exploded, Sisimiut was in the perfect spot to adapt and, really thrive. So what gives? Why the completely different outcomes? The answer, and this is really the key, isn't just about the fish. It's about the deep-down social and economic fabric of the communities themselves. Researchers have this great framework for understanding this, using what they call 4 capitals. First, you've got natural capital. That's the other resources that were available, like the shrimp that Sisimiut could switch to. Then there's physical capital, having the right boats, the right factories. Human capital is all about the skills and the knowledge of the people. But crucially, and this is the one people often forget, there's also social capital. That's the trust, the collaboration, the social networks in a community that let it work together to adapt. Sisimiut just had a stronger mix of all 4. This quote right here, it just nails a really common misconception. Climate change doesn't happen in a vacuum. The impacts we actually feel are the result of this complex dance between the changing climate, how the ecosystem responds, and then how we use resources. It's that messy interaction that really determines how things shake out. Okay, so let's pull the lens back out again, because the lessons we just learned from Paamute and Sisimiut about being resilient, well, they apply directly to a massive global challenge: rising sea levels, which are being fueled by that same ice melt we talked about at the beginning. Just take a look at this map. It really paints a stark picture, doesn't it? The parts in red show areas of the U.S. Gulf Coast that are already dealing with high tide flooding. This isn't some problem in the distant future. It's happening right now for millions of people who live in low-lying coastal spots all over the world. And here's another really important point, a common misconception, actually. It's easy to blame everything on rising seas, but the truth is, a lot of what we've done on land is making things way worse. Think about it. We've encouraged people to settle in these vulnerable places for centuries. We've made the land itself sink by pumping out groundwater, and we've destroyed natural storm buffers like wetlands. These things can actually make a place more vulnerable even faster than the sea is rising. And that rise, it's picking up speed. Projections show that a lot of places around the world can expect up to 40 centimeters. That's about 16 inches of sea level rise in just the next 3 decades. That's not some far-off future. That's well within the planning window for today's critical infrastructure. So, with all this happening, what are we actually doing about it? Well, it turns out there's no single answer. Instead, there's a whole range of strategies that communities are looking at and starting to put into place all over the world. You can basically group the responses into 5 main buckets. The classic one is protect, building big, hard things like seawalls. Then there's advance, which is where you actually create new land. EBA, or ecosystem-based adaptation, is about using nature itself for protection, like restoring mangroves. Accommodate means you learn to live with the water by doing things like raising houses. And then there's retreat, the really tough decision to move people and buildings away from the danger zone.
But, and this is a big but, none of these are a magic wand solution. Building walls is super expensive and can wreck ecosystems. Moving entire communities has huge financial and social costs, and if it's not done right, it can make inequality even worse. The big takeaways here is that every single option involves some really hard trade-offs. Getting it right really comes down to having fair, inclusive, and complex planning.
And that really brings us to the heart of the matter, to our final big question. You see, the challenge of a changing climate isn't just about engineering or economics. At its core, it's a deeply human question. As our maps are literally being redrawn by the water, we have to figure out not just what to save, but how to save it, balancing the concrete need for protection with the equally vital but much harder to measure need to preserve the culture and the very soul of the communities on the front lines.